So the first half of this course is a whole lot of algebra. We're going to continue on with something that maybe should have been part of the review unit. You may or may not have done solving equations before. So if you remember where we left off in Unit A, we were evaluating expressions or we were simplifying expressions by adding and subtracting terms or multiplying and dividing terms. So now we're going to have statements that include an equal sign because we're moving into equations. So that's how this unit B is different. We will be coming up with an answer like solving for x in all of these. So B.0 is because it was added into here. We're solving one variable equation. So we know that an equation has two expressions equal to each other. So an example of this would be x plus 3 equals 5. So x plus 3 is an expression and 5 is an expression of just one term. We could make it more complicated, but there's no need. Now, intuitively, you know the answer to this. This is saying what plus 3 equals 5? Well, x would equal 2. We can figure that out just intuitively. We're going to practice in this B.0 the strategies of solving equations. So we understand to solve an equation, we need to get a variable all by itself, right? We want just the x on one side and just the numbers on the other. We do this by applying two different properties in math, but you might not have remembered the names of the properties. You might remember some of the mechanics. A good summary is that anything you do to one side of the equation, you have to do to the other. It's like having two children. You have to treat them equal or people get angry. You can also think of it as a balance, right? If we do something to one side, then we do something to the other. If I take this example that you knew intuitively and apply that process, what I'd like to have is just x all by itself. Well, the problem with having it as it is that I have this plus 3. If I didn't want the plus 3 on this side, I could subtract 3 from both sides. That would get rid of it on this side, and I have isolated my x. I have solved for x. Now I just have to do the math on this side. So this would equal then 5 minus 3, which is the 2. So it's the same answer. Your powers of intuition got you to here, just figuring out the puzzle. Or we do have these mechanisms that for when things get harder, they can be pretty handy. So if we are solving equations, we will get a solution, and a solution to an equation is a number or numbers that make the statement true. So we can check or verify a solution always by subbing in those values and see, does it check out? Does the left side equal the right side? Now there's many ways to do this. I tend to do it in a little chart. So let's practice checking some of these solutions. So for A, this says that here is my equation and my potential solution. So to verify this, I would take the left side of everything over here and the right side of everything over here. So I'm going to sub in, I'm going to evaluate the left side with x equaling 3. So I've got a 2 times that 3, because that was the x I'm subbing the 3 in for, plus 4. The right side is just 10. What I'm hoping is that the left side equals the right side, and this checks out. So 2 times 3 would be 6, plus the 4 equals 10, and everything is awesome. So that means that 3 is a solution. We've verified the solution for this equation. Let's try another one. We have a more complicated equation over here. We have a potential solution. So if I want to check this, if I want to verify the answer, I'm going to make a simple little chart kind of breaking down the equation into the left side and the right side. And I'm simply going to evaluate each side to see if it checks out. And this 5 makes the equation true. So all I'm doing is copying out the left side, subbing the 5 in for the x. And I'll do the same on the right side, subbing the 5 in for the x. And now I'm going to do the math. Check out to see if they actually do equal each other. So I'd have 15 minus 2, or 13 on the left-hand side when I tried out x equaling 5. And on the right-hand side, I'd have 10 plus 1, or 11. So that tells me the left side doesn't equal the right side. That means that this is not a solution for this equation. There might be another one, but I have verified this and it failed, basically. So give this one a try. We've got an equation here, and we've got two different possible solutions. Is 4 a solution? Is 6 a solution? And what we're saying, can x equal 4? Can x equal 6? And what we want to do is check this answer to see if it actually makes things true. So I'm going to break this up into the left side and the right side. And you don't have to do it in a chart, but I tend to find when I look back at my notes, it makes it look a little bit more sensible. And I'm just subbing in the 4 wherever I see the x. I'd have 8 minus 1 and 4 plus 5, which is 9, and 7. So in this one, the two sides don't equal, so which that means that 4 is not a solution. Let's try the last one. So same equation, but now we want to check, is 6 a solution? So left side, right side. Subbing in 6 where I see an x. You might be able to do this faster. I'm still trying to sub in with brackets, use all my good practices. And in this case, both sides end up being 11. And so what that tells me is that 6 is a solution. Now, if you were to do this, if you were to just try all the numbers to try and find a solution, it would take you a heck of a long time to do the next pages. So we're going to use a property in math that gives us a strategy to solve these things. So we're basically going to move things around so that x equals just one number. So the addition property in math says we can add or subtract anything to either side of the equation so long as we treat them the same. So in this one, and you may have learned this a little differently, so I'm going to be consistent in how I show my work, but if you are good on this and you remember it, then go ahead. If you can get to the answer, as usual, you're good. So this is my original equation. What I'd like to get down to is a solution where x equals a number. So in this one, I could do this intuitively, but we're going to practice moving things around. I want x by itself. So the thing that's blocking me from having x by myself is this minus 3. If I wanted to get rid of it, I would have to add 3 to this side of the equation. Well, I can't just do that. If I give 3 cookies to one kid, I have to give 3 cookies to the other kid. So in this case, those 3's cancel out. Negative 3 plus 3 is 0. Or just an x on this side equals 9 plus 3, which is 12. And I could always double check my work on this one. I can kind of look at it and see, but just really being consistent with my strategy here. It's all well and good when things are easy and you can just see the answer. But if you need a strategy to get to the solution, then this is pretty good to show your work. So you might remember these ones. We're going to practice a few of them. I'm going to talk my way through all of these pages. If you don't require that, if you want, you can always just use my printed out answer key that's available on the Moodle site, or you can just kind of fast forward and check your answers as we go. But I'm going to talk through each one because sometimes, we need a little bit of extra support in this. So for these ones, because they are equations, we can solve them. We can say what x equals. And we can verify, which means this left side, right side, we could check these. In all honesty, the checking is super tedious. If I have an answer key, that's how I'm going to check my answer. But for this first one, I'm going to just stay with this. It is tedious, but it's a good idea. Okay, so in A, if we want x all by itself, what my problem is having this minus 5 over on this side of the equation with my x. So if I add 5 to this side of the equation, that would get rid of the negative 5, and I'd have just x by itself, but I would also have to add 5 to the other side. So if I take a look at the next line, adding these kind of vertically, if you will, it's just the way I show my work, x would equal 9. And I could double check this, left side, right side. This is the only one I'm going to verify because it's super tedious. 9 minus 5, and yeah, that's 4. I got the right answer. So always looking at these, we're doing the addition property, so you can add or subtract to get rid of things or get the x by itself or solve these equations. In B, I would subtract 5 from both sides. That is going to get rid of the 5 over here, and I'd have the x all by itself. On this side, I have 9 minus 5, or 4, and that gives me my solution. Again, if you want, you can verify this one. In my notes that I'm looking at, I was already a little too lazy to check, but you could also just look back. Yeah, 4 plus 5 is 9. That makes sense. These ones are still in the realm of being intuitive, where you don't need this strategy. So the last one, I would subtract 6 from both sides of my equation. So I would have x equals a 7. And again, I could check those answers by verifying the left side and the right side, or I can even just look back on it. It makes sense. So things are going to get a little bit more complicated here. These ones are a little less able to be done intuitively. So in this case, we've got an x term and an x term. We would like all the x's on one side and all the numbers on the other. This is kind of our goal. This is how we're going to try and move things around to solve these equations. So previous to this, I've been adding and subtracting numbers, whole numbers. I can also add or subtract like terms. So if I subtracted 4x from this side, moving the x's to the left and the numbers on to the right, I would have minus 4x on this side. If I subtract 4x from one, I have to subtract 4x from the other. Sorry, I was just trying to get rid of that. Okay, so that gets rid of my 4x. 5x minus 4x is 1x, or I could just write that as equal to x. And on the other side of my equation, I have a 7. Let's just, because this one's just a little different, let's check this one, left side and right side. We're going to verify this solution. So if I plug a 7 in wherever I see an x in the original equation, right, I should get this thing to check out. So I'd have 35 on the left side, I'd have 28 plus 7, or 35 also on the right side. And that's what tells me that x equals 7 is the correct answer. It is the solution to this equation. There's a few more like this. So we want to get x's on one side, numbers on the other. I'm going to pick on the x terms first, always. I want to put all the x's on the left. In this case, I've got nothing on that right-hand side, so that's going to equal 0. I'd have 9x minus 8x, that's 1x or just x. I still have this plus 3, I haven't dealt with it yet. What I can do now is subtract 3 from both sides. So I'd get that x equals a minus 3. I could verify this left side and right side. Basically plugging, a 9 times minus 3 in everywhere that I see it. 8 and minus 3. So I'd get negative 27 plus 3 and negative 24, or negative 24 equals negative 24. Now in this one has something that's just a little bit different, and you may have done this a little differently. You can choose to subtract 3 from both sides first. This 0 here is a bit of a sneaky thing, right? If you have nothing left on this side, it still has to be preserved as an equation, right? And so that's why this question is in here in the examples, because it's just a little bit different. I'm going to stay with my strategy on these ones. I'm going to move the x terms first, so I'm putting all the x's on the left and all the numbers on the right. In B, I would subtract 6x from both sides. That would eliminate my x terms from the right-hand side of my equation. I have 7x minus 6x, so that's 1x, and you can write 1 if you want. I'm just going to write an x, equals 3. If I were to check this one, and I was looking at my notes and I was still checking. Boy, I was being a good sport. So 7 times 3 is 21, and 6 times 3 plus 3 is 18 plus 3, or 21. So that tells me that x plus 3 is the right answer. It's the solution to that equation. The last one, more going on. I'm going to start with my x terms. I'm going to put all my x terms on that left-hand side, eliminating them from the right-hand side. So now I would have 1x, so 4x minus 3x, or x. I'm just going to copy everything else. You can do more than one thing in a step, but I find that I tend to make mistakes. And so I just slow it down. I'm only going to do one thing at a time. And making these decisions to eliminate something or move it around. And the last one, left side, right side, plugging my answer back in, I can always check that I haven't made a silly math mistake by plugging that 7 in for x and see if the two sides of the equation actually equal each other. So in this one I'd have 28 minus 5, or 23, and this side I'd have 21 plus 2, or 23. Obviously they equal each other, and that tells me that this is the correct solution for this equation. So we're going to step it up. Each one of these is going to become a little bit more complicated. In solving equations, I find it easiest to do one step at a time, but also to gather like terms first. And so when I take a look at this first example, I have whole numbers on the left and x terms on the right that I can kind of gather up, if you will. That's the way I say it anyway, just to make this a little bit simpler. So I have 5 minus 2, so that's 3, plus the 8x. They're not like terms, so I can't do anything more on this side. Gathering the like terms on this side, I'd have 2x and a 5x, so a 7x, and copy that minus 3. And now I have an equation that's a lot like those last ones that I was just working with. So I'm going to move my x terms over to the left first, and I move them by eliminating them on the right. I'd have 3 plus x, 8x minus 7x is 1x. And then on the right-hand side of the equation is still that minus 3. Now I still have this 3 over here, so I don't have just the x, I haven't isolated the x. So I'm going to subtract 3 on this side and subtract 3 on that side. 3 minus 3 is 0, that goes away, right? It gets rid of it, moves it to the other side, if you will. X would equal negative 3 minus 3, watch your signs on this, use your calculator to catch yourself from making silly mistakes, and I get that x equals minus 6. You might want to pause it and give this one a shot. This one's similar in that it has some like terms to gather up first. So I gather up the 3 and the 4 to the 7, and I gather up the 8x and the 3x to the 5x, copy out that minus 3. And now I'm going to pick on the x terms first. I'm going to make sure there's no x terms on the right-hand side. I want to get rid of them on the right-hand side. If I do that minus 5x on one side, I have to do it on the other. So I get 7 plus 6x minus 5x gives me 1x equals a minus 3. And I'm not quite done. I still have this 7 hanging out with the x. I want just the x on one side. I'm going to subtract 7 from both sides, getting rid of it on the right, or sorry, that's the left. Gosh, I've probably said left and right wrong a couple times already in the video, sorry. And x equals a minus 10. Stay with me. The next thing we're going to do is use the distributive property. So we've seen this a little bit in the course where you can't do order of operations here, right? Order of operations would say you have to use brackets first, then exponents, then division, multiplication, addition, subtraction. If we can't get past the bracket part, in algebra, we're stuffed. We can't actually solve this. So distributive property is really important to break up those brackets in a way that's legal in math. So we'd have 2 times 3x, so 6x, and 2 times 4, so plus 8. That's my distributive property. And now I'm going to copy out the other side. And now that I've moved past my brackets, I can move on and solve these things. So I'm going to pick on my x terms first, subtracting 5x from both sides, because that's what gets rid of it on the right there. 6x minus 5x is 1x. I'm going to copy everything else down. I'd want the numbers on the right, so subtracting 8 from both sides gets rid of it on that side where I want just the x, and that tells me that x would equal a negative 14. You sure could verify these ones. Honestly, in my notes, I don't because I'm a little lazy and I check my answer key. But knowing that this is like possible, I think is the key bit here, right? Like doing it is one thing, but knowing you can do it is a bit of another thing. So let's do another one. Again, if you want to challenge yourself, we're practicing the distributive property first, and then we'll move on and solve these. So the distributive property is what I'm going to do first. So that tells me 3 times 5x is 15x, and 3 times positive 1 is plus 3. I also have some distributive property to do on the other side. So that's 2 times 7x, which is 14x, and then 2 times negative 3, which is minus 6. And oh, I had a little negative 4 sticking out the back there. So I've done this distributive property step. Now I have a few like terms that I could gather up here. On this side, and you don't have to do this next, but like modeling the way the notes are kind of coaching us through it, this is something that made things just a little bit easier to deal with. So negative 6 minus 4 is negative 10. Watch your signs. Use your calculator as a tool. Next thing I'm going to do is minus 14x from both sides. What that does is eliminate it on the side that I just want numbers. Now 15x minus 14x is just 1x. And the next thing I'm doing is just copying everything else that I still have going on. I want numbers all by themselves and x's all by themselves. So to get rid of that plus 3, I'd minus the 3, but I have to do it on both sides. And my last line here would be that x equals a negative 13. So a few more on the page here before we get into the other part of this, and this is a bit of a longer video. We're going to distribute a negative number. So nothing different in this, but just watch your sign. So we'd have negative 2 times x, so that's negative 2x. Negative 2 times negative 5 is a positive 10. And then I'm copying the rest over here. I'm always going to pick on the x terms first. I'm going to add 3x on both sides because that's what gets rid of it over here. Negative 2x plus 3x gives me a positive 1x. I'm copying everything else as I go. And now I have to subtract 10 from both sides. I want the x all by itself. So get rid of the 10 over there by doing the opposite. You might have learned it that way. I get that x equals a negative 8. Try the next ones on your own, or you can watch me go through them. I'd have negative 4 times 2x, and then negative 4 times negative 1. Watch your signs. I'd have negative 3 times 3x, and negative 3 times a positive 2. I'm going to pick on the x terms first. I'd have an x plus 4 equaling negative 6. I'm going to subtract 4 from both sides because that's what gets rid of it on this side. And I get a final answer that x equals a negative 10. I'm going to go a little bit out of the regular here. I'm going to do E first because I know that C has something of a wrinkle in it. So E also does. What you can imagine here is an invisible 1 sticking out the front. So what we have is negative 1 times 2x, so negative 2x, and negative 1 times a positive 3, so negative 3. I'm going to copy everything else out. I'm going to pick on the x terms first, doing the same to both sides. So I'd have an x minus 3 equaling a 7. I'd add 3 to both sides, to get my solution to this equation, I can solve this equation, not just simplify it or evaluate it, but solve it at x equaling 10. So to this point, I have always been putting the x's on the left and the numbers on the right. I've been moving the x terms first. If you're feeling a little more comfortable, or maybe you went rogue, maybe you did it on your own, you might have got to the answer by doing things in a slightly different order. And so you don't have to know which way to do things. We're going to do this one in the same order that we've been doing things. Watch the negative signs. This one is primed to make us fall into a bit of a trap. So my x's would go away on this side. Watch your signs on this. Negative 2x plus x gives me a negative 1x, or a negative x. We haven't seen that yet. All the other ones, the x's have just worked out. I'm going to continue on and deal with my whole numbers like I have been. And now I have negative x equals negative 1. Now this is really the key part of the next pages that we're going to go through. We don't want to solve for negative x, we want to solve for x. If I know that there's a negative 1 in front of that x, I can get rid of it by dividing, right? We've been doing the opposite in all of these operations. What's going on between the negative 1 and the x here is multiplication. Well, if I do the opposite and divide, that gets rid of my coefficient. So I get an answer that x equals 1. Like I say, that's a bit of a teaser into the next part of the videos. And I think I'm going to break it up here just so that these are a little bit shorter. That's an awful lot to digest.